Yes, members? Members?
Yes, teacher.
Are we together on this?
Yes.
Very good, very good. So that's the difference between virtual and real what? Real image. Image. So you find that when you place the mirror, the plane mirror horizontally on the ground, okay? The image is formed. The image is what? The image is what?
It's formed.
The image is real. The image is what? Real. But when you place it vertically, the image is what? The image
Virtual.
The image is virtual. Why? The major difference here is, remember, the major difference between real and virtual image is that for real image, it is formed on the screen. It is formed on the what? On the screen. But for virtual, it is formed behind the screen. It is formed behind the what? The screen. So you add it here. You add it here. Behind the what?
The screen.
Behind the screen. Behind the screen. Then another thing you must also observe when you are drawing images, we are going to look at it in details when we look at plane mirrors, okay? When you are drawing this distance here, I think this distance here,
Yes.
the object distance must be equal to the image distance. The object distance must be equal to the image distance. So this is our U, this is our what? Our what? Our V. So for plane mirrors, object distance, object what? Distance is equals to what? Image what?
Distance.
Image distance. That's why if you stand on a dressing mirror, if you are close to the mirror, even your image appears to be closer to you, not so. If you go far away from the plane mirror, even your image appears to be far away from you. Okay? Yes, that is V equals to what? V equals to U. That is for plane mirrors. For what?
Plane mirrors.
Now, like Patricia was saying, someone was somewhere there. Was it Patricia? I think it was Patricia. Patricia said, when you stand on a dressing mirror, you see that this, if you are short, even your image appears to be short. Not so.
Yes.
The image does not change. The image does not what? Change. You appear to be real. You appear to be what?
Real.
Be careful with my word. I'm using the word what? Appear to be real. Which means it's not what? Yes. So what does that one mean? So which means if the object distance is equal to the image distance, which means magnification for plane mirror is what? What's the magnification? What's the magnification?
1.
The magnification for plane mirror is 1. Good. That's not change. That's not what? Change. So come and say here, linear magnification, linear what? Magnification. M is equals to V over what? U. Okay? You come and say since V is equals to what? Since V is equals to what? U, it implies that V is equals to, so I can have V over what? Over V. I think that. Which means it will give us what? They give us 1. It give us what? 1. So it says linear magnification of a plane mirror of a plane what? Mirror is what?
1.
Is 1. Is 1. That is the size of the image. The size of the image is equals to the size equals to the size of the what? The size of the what? Of the object. We shall look at that one in details when we are looking at plane mirrors. Are you together?
Yes.
Yes. Members.
Yes, teacher.
Sample question. Sample what?
Question.
Sample question. Give the differences. Give the differences between real and virtual image. Give the difference between real and virtual image. Who can give us one? Who can give us one?
Me.
Yes, please. Who is that?
Fiona.
Yes, Fiona.
Real image is found on the screen, while virtual image is formed behind the screen.
Is formed behind the screen or not on the screen. Okay.
Yes.
So what you can do that you can use a table. You can use a table to give a difference, or you what? Or you can give it in words by separating them with the word while. With the word what? While. But in physics, we prefer using a table because it makes it much easier. So here we shall put what? Real what?
Image.
Real image, then virtual image. And your answer, they must be chronological. They must be what?
Chronological.
What do we mean? When you said real image is formed on the screen, which means the other one, they must be in the same line. They must be chronological. They must have the same meaning. They must have the same what? Don't say real image is formed on the screen. Then the other one you said it is an image which is formed by the apparent intersection of light rays. So they are not chronological, okay?
Yes.
This one formed on the screen. This one is formed on the what? On the screen.
Yes.
Then this one is just say not what? Not formed on the screen. Or behind the what?
The screen.
Behind the screen. And they must appear to be in one line. They must be in one line. So which means the second one must start from down here so that they appear to be in one line. What's the second one? Who can give us the second one? Nalokenga has given us here. Real images are formed by real rays of light. Good. Real. Nalokenga, that one is correct. You said formed by actual, not to avoid repetition of words, because I'm saying real image and it said real image. So you just use another word, virtual. Right together, Nalokenga. Use the word what? Actual. Formed by actual intersection of light what? Light rays. Then the second one is formed. This is formed by what? Apparent. This is formed by apparent intersection of light what? Light rays. Then you close. Then you what? You close. A table must always be closed, members. A table must be what?
Closed.
Must be closed. Yes? Yes, please.
Let me see. A real image is only formed on
the screen.
On the plane, maybe on the screen, but I mean this pinhole camera, is it the only that produces a real image?
No, there are very many. We shall look at them. There are very many. As long as, okay, what is important here is to know that as long as the image that is formed is on the screen and is formed due to the actual intersection of light rays, that image, we call it real image. Okay?
Okay.
Yes. But the one which is not formed on the screen or is not formed by the actual intersection of light rays, that one we call it virtual image. Are you together? And
Yes.
how do you know that the image form is real? The image form, one, if you are using a ray diagram, if you are using a ray what? Diagram,
Yes.
for real, we use solid line. For real, we use what? Solid what?
Line.
Real image, we use solid what? Solid
Line.
what? Solid lines. We use solid what? Line. Okay? Then virtual image. The rays are drawn using dotted what?
Dotted lines.
Dotted lines. Have you seen it, Letitia?
Yes.
Very good, very good. And so I was asking, what type of image is formed in the eye? Which type of image is formed in the eye? Is it real or virtual? Who can answer for us that? The one that is formed
It's real.
is what?
Real.
Is real. The image is what? Real. Because it's formed due to the actual intersection of light what? Rays. That's why you are able to say this one is it. This one is what? You can be in position to give the colors of the object. Okay? Are you together?
Yes.
Yes. I think we are together on that. We are together on that. We are together on that. Subheading, reflection of, before we go to reflection, let's write this one down. Let's write this one before we go to reflection of light. Let's write this one down. Properties of light. Properties of what?
Light.
Of light. Properties of light. Properties of light. Who can give us one? Who can give us one? What are the properties of light that we know?
Light travels in a straight line.
Good. It travels in a straight line. Very good, very good, very good. It travels in a straight what?
Line.
In a straight line. That is one. Good. Next. Who can give us another one?
The image is the same. Me, teacher.
Yes. Yes.
The image is as the same size as the object.
No. That one you are giving for devices. That's the sources of light. But we are looking at the general aspect of light. Okay? What are the properties that give what define light? One, it travels in a straight line.
It's
Someone can say it is a what?
Laterally inverted.
It is what? It is a form of. It is a form of what?
Energy.
It is a form of energy. Properties of light. We are given general form. Okay? General properties. Okay? What else?
Light is an electromagnetic wave.
Good. It is an electromagnetic what? Waves. Good. It is an electromagnetic what? Wave. Good. What else? What else? It can be what? It can be what?
Fused.
It can be reflected. It can be what? Refracted. It can be what? Reflected. It can be refracted. It can be what? It can be what? It can be diffracted. It can be diffracted. We shall look at them. We shall look at one of them one by one. It can also be what? Someone has given. It can be polarized. Good. What else? And undergoes interference. And also undergoes what? Interference. Inter what? Interference. Those are the properties of light. We can also add it travels at a speed, at the speed of what? What is it? Who can give us speed of light? They travel at the speed of 3 point,
3.
3.0
3.0 times 10 to the power
to the power what? 8
8
meters per
second.
meters per second. Someone also said it can also be dispersed. Dispersion of light. Dispersion of light. It can also be what? This what? Dispersed. So I'll also look at,
Dispersed.
I shall look at them one by one. Okay.
Yes.
Then another one. It also travels what? It travels in a what? In a what?
The vacuum.
In a
The
vacuum.
vacuum.
In a vacuum. Those are the properties of light. Those are the properties of what?
Light.
Light. Now let's start. I'm going to pick the key ones that we are going to look at them in details are these ones. Okay. It can be reflected, refracted, diffracted, polarized, and can also go interference. It can also be dispersed. It can also travel in a vacuum. But let's start with the first one, which is reflection of light. Subheading, reflection of what?
Light.
Reflection of light. Reflection of light. Reflection of light. We said reflection is a process by which light energy falling on a body surface bounces back. Is a process by which light energy falling on a body surface bounces what? Bounces off. Or someone can just say is the bouncing. Is the bouncing back of light when it strikes. We have all these notes. I'm just going to explain. Should not take a lot of time on this. Okay?
You don't have.
You don't have the notes?
Yes.
Yeah, go to the website and download the book, okay?
Which book?
You will see
Which
that
book?
physics O level. You see physics O level on the website. Physics O level. Okay?
Okay.
Yes, it contains all the topics in physics. So definition, reflection of light, is the bouncing back of light when it falls or strikes, when it strikes,
Yes.
a reflecting what? Surface or shining surface. Reflection is the bouncing back of light when it falls or strikes, when it falls on or strikes a reflecting surface or a shiny what? Surface. That's what we call reflection of light. Members, reflection is a very important aspect in physics or under light because we are able to see because of reflection. We are able to see everything, human beings, the rays that fall into our eyes is due to reflection of light. So you find that light rays, you are able to dress. You are able to stand on a dressing mirror and dress very well because of reflection. Because your image will be reflected into your eye. That's why you will be able to see that. I think there's a problem here. I have to check that. Okay? Are you together, members?
Yes.
Yes. So reflection is a very important aspect. And sometimes Sometimes if you want to determine the degree of your madness, you can also use a plane mirror. Are you aware of that? If you want to determine the degree of your madness, just even before going to the psychiatrist or to do what to the psychologist to do anything, just go to the dressing mirror and determine your degree of madness from there. Whatever you do on the dressing mirror, determine the degree of your madness. Some of you will start bringing their teeth out, you start opening your mouth, you start putting what you are not sure of what, which means, whatever you do that determines the degree of your madness. Eh? Patricia? Alexandra? Yes, so if you want to determine the degree of your madness today, just go to the dressing mirror and try. Whatever you do on the dressing mirror, don't even tell anyone. Just whatever you're going to do on the dressing mirror will determine the degree of your madness. But it will become extreme, then we see you on the streets. We are all mad, but when yours get extreme, we shall start seeing you on the street these days. Jordan is just laughing. Okay. Members, are we together on that? Members, are we together?
Yes.
Yes. So reflection. Members, we have two types of reflection. Or before we look at type of reflection, let's look at some of the terms. So let's say terms used. Terms used in reflection. Term used in reflection of light. Term used in reflection of light. Term used in reflection of light. Let's say consider a ray of light. Consider a ray of light. Incident on a reflecting surface. On a reflecting surface as shown below. Consider a ray of light incident on a reflecting surface. So let's draw a ray. Let's draw this, please. Let's draw this. So M prime. Let's say this is A or B. Then let's say this is N. That is N. That is N. Members?
Yes.
Yes,
Yes,
teacher.
teacher.
Have you drawn that? Have you drawn that?
Yes.
Yes.
Good. So number one, let's look at number one. The terms that we are going to derive all the terms from this ray diagram we have drawn. The first one is what we call the incident ray. The first one is called the incident ray. The incident ray. And from the diagram that is indicated by letter A, what? A what? AO. Okay? What is the incident ray? Incident ray. This is a ray of light. This is a ray of light. This is a ray of light which strikes or falls on the reflecting surface. On the reflecting surface. In this case, our reflecting surface is M prime. Okay? So the ray that is directed onto the reflecting surface, that ray is called the incident ray. That ray is called the incident ray. Then number two, we have the reflected ray. Reflected ray, which from the diagram is presented by O what? O what?
B.
OB. We said this is a ray of light. 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 This is a ray of light which has been bounced off, from the reflecting surface, surface. That ray is called what? Reflected ray. Number three, we have what we call point of incidence. Point of incidence. And from there is just letter O. This one. This is what we call point of incidence. This one. Okay? Members, are we together? Are we together?
Yes, teacher.
Okay. We said this is a point. This is a point on the reflecting surface. This is a point on the reflecting surface. This is a point on the reflecting surface where the incident ray, the normal line, and reflected ray meet. A point of incident, this is a point on the reflecting surface where the incident ray, the normal line, and the reflected ray meet. Now that one will also lead us to another point. From here we have a new word, a normal line, normal. So next one should be normal line. Next time is normal line. From our diagram, our normal line is O, or what? ON. That line is called normal, and it must be dotted. Why we think it's dotted? Because that line is virtual. That line is what? Is virtual. It's not real, but we assume that is there. We assume that that line is there. So that's why we draw it using a dotted line. So what is a normal line? What is a normal line? We said this is a line. This is a line. This is a line which is perpendicular. Which is perpendicular to the what? To the what, members? To the reflecting what? Surface. Which is perpendicular to the reflecting surface. Are we together? Are we together? Are we together?
Yes.
Yes.
Good. So a normal line is a line which is perpendicular to the reflecting surface. Those are the common of the terms. So those are the sum of. Now let's come back to our diagram and add some features there. So let's call this angle I. Then this angle, we call it angle R. This angle here, let's call it angle R. Let's call it angle R. Then this one, let's call it G. Let's call it G. Then the angle, let's add some more features there. So this angle from here up to there, up to that one, this angle we call it D, angle of deviation. That angle is called angle of deviation. Members, our time is running out. Our time is running out. Let's try to hurry. Have you put those ones? Have you put the features there? Members, have you put it?
Yes.
Yes.
All right. Still on the normal line, for the normal line, write this one under normal line. Note, a normal line is not a ray. A normal line is not a what? Is not a ray of light. Is not a ray of light. And therefore, should not be drawn with an arrow. Should not be drawn an arrow on it. A normal line is not a ray of light and therefore should not be drawn with an arrow on what? On it. Are you together, members?
Yes.
The next one is what? Number what? Number 4, number 5. 4 or 5? Number 5. Let's look. Number 5. Number 5, angle of incidence. Angle of incidence. Angle of incidence. Angle of incidence. So from the diagram, we have noted with what? We use letter I. We use letter I. So who can define first angle of incidence now? We said this is it. This is the angle between what members? Who can define us that? Look at the diagram and then define. This is the angle between. Who can define first that? This is the angle between?
Between the incident ray and point of incidence.
And the normal line, and the normal line.
And the normal line.
Yes. So this is the angle between, this is the angle between the incident ray, the incident ray, and the what? And the normal, and the normal line at a point of what? At the point of? At the point of what? At the point of incidence. This is the angle between the incident ray and the normal line at a point of incidence. And it's denoted by letter what? Letter I, small I. Number 6, angle of reflection. Angle of reflection. Angle of reflection. And from the diagram, we have used letter what? R. So who can define as angle of reflection now? What is angle of reflection? Members, who can define for us that angle of reflection? Yes?
Is an angle between the normal line and the refracted ray.
Is the angle. Don't leave out this word at a point of incident, please. You make it complete. Make it complete now. That is Esther, not so.
No,
Yes, who is that?
Alexandria.
Yes, Alexandra.
The angle of reflection is an angle between the normal line and the reflected ray at the point of incidence.
At the point of incidence. Good. So this is the angle. This is the angle between the normal line, between the normal what? The normal line and the reflected what? And the reflected ray at a point of what? Incidence. At a point of what? Incidence. Which other angle we did not talk about? Which other angle? Number 7. Which one is left there from the diagram? G, not so? G is called glancing angle. Members, G is called what? Glancing angle. G. From the diagram, we have labeled it as G. Glancing angle. Who can give us that angle? When you look at it from the red diagram here, when you look at it from here, this is the angle we are talking about. I think this one, okay? Okay? So who can define for us? You can see, is it this one, this one? What is that angle? Is the angle between? Is the angle between? Is the angle between the incident ray and the reflecting what? And the reflecting surface. At the what? At the point of incidence. At the point of what? Incidence.
Yes.
So we said this is the angle. This is the angle between. This is the angle between the incident what? The incident ray and the reflecting surface. And the reflecting what?
Surface.
And the reflecting surface. Do we stop there? Do we stop there?
No.
At
the point of incidence.
At a point of incidence. At a point of incidence. Very good. Or members. Now, when you look at this one, now let's go back to our geometry. You see this angle here is G, not so? Not so?
Yes.
What about this one? What about this angle here? What about this one here? What about this one? That angle is also what?
That angle is also what? G.
G. Which property is that? Which property is that? Which property is that? If you remember your geometry very well, which property is that? Is it alternating? Is it opposite? Which property is that?
Opposite.
Is it opposite?
Alternating.
Yeah.
They are alternating, not so?
Yes.
Yes, and we said alternating angles are always equal. Alternating angles are always what? Equal. So which means
Equal.
someone can also say, is the angle, someone can also say, is the angle between, the reflected what? The reflected ray and the reflecting surface. And the what? And the reflecting surface at
A
a
point
point,
of
at a point of what? At a point of incidence. At a point of what? Incidence. Members, are we together on that?
yes.
Our time is running out, but next time we meet, we shall look at angle of deviation. Angle